Hello, this is Miss McCauley, and today we will be working on functions. This will be part 1 of the video. Please make sure to answer the note check when you finish this part. Go ahead and go to the next page as soon as you're ready. A function is a relation that assigns exactly one output value to one input value. The number of wing beats, output, depends on the number of seconds, input. The function rule describes the relationship between each input and output. We call that the function rule. You can organize the input-output values and the function rule in a function table. In a function, the input value is also known as the independent variable, since it can be any number that you choose. The value of the output depends upon the input, so the output value is known as the dependent variable. What that really means is that your input, which is your x, is the independent variable, and the output, which is your y, is the dependent variable. Okay? Okay, let's look at a couple of examples. Let me just scroll down just a little bit. The output is 7 more than the input. Complete a function table for this relation. The function rule is x plus 7. That means that you're taking the x, which is your input, and adding 7 to it. So you add 7 to every input. So what you get, if you have a table, you put the input here, which is your x, your rule here, and your output, which is your y. I'm going to write y there just so we remember that that's your y. Okay, so if we do that, you can see that if our input is 10, 12, and 14, and we add 7 to each one, we get 17, 19, and 21. That's how you complete a function table. Let's look at number 2. The output is 5 times the input. Complete a function table for the relation. The function rule is 5x, meaning 5 times x. Remember, whenever you have a number next to a variable, that number right there is your coefficient. Let's just write that down so we remember. Any number in front of a variable like that is a coefficient, and it's multiplying. Okay, so if our inputs are 8, 10, and 12, we would put in the rule 5x, and we would write 5 times 8, 5 times 10, 5 times 12, and then we would calculate our outputs. 5 times 8 is 40, 5 times 10 is 50, and 5 times 12 is 60. So far, pretty easy, right? Why don't you go ahead and try problems A and B on your own, and then we'll check our answers. The inputs are x, the outputs are y. Your rule on this one is x minus 4, and your rule here is 3x. Okay, hopefully you had time to solve problems A and B. Let's meet up with our new function helper and get the answers to these problems.
Hey there, I'm Freddy Functionburger, and I've got some answers for you. For problem A, your output should have been 0, 3, and 6. For problem B, your output should have been 0, 6, and 15. If you didn't get those answers, please check with your teacher.
Okay, thanks, Freddie. Let me show you how we got those answers, just in case you aren't sure. The way you do this is you simply take the x, plug it into the rule. So 4 minus 4 is 0. 7 minus 4 is 3. 10 minus 4 is 6. For this side, it's simply 3 times the input. So 3 times 0 is 0. 3 times 2 is 6. And 3 times 5 is 15. That is all you have to do for these. Very easy, right? Go ahead and go to your next page. Okay, what happens if you're given the output and you need to find the input? The input and output of a function table can be represented as a set of ordered pairs, or a relation. The input represents the x value, and the output represents the y, just like we just talked about already. And remember, ordered pairs, you should have learned this in social studies already. Ordered pairs are written like this: x, y. X always goes first. So let's take a look at this example. Find the input for the function table. The output is 6, 15, and 21. The rule is 3x, meaning 3 times something equals 6. You can use the work backward strategy to determine the input. If the output is found by multiplying by 3, then the input is found by dividing by 3, because dividing is the opposite of multiplication. So 3 times what is 6? Well, you should know that 3 times 2 is 6, so our input value is 2. What times 3 is 15? Well, 3 times 5 is 15, so our input is 5. And 3 times 7 is 21, or 21 divided by 3 is 7, so that input is 7. Okay, let's try these problems right here, C and D. I'd like you to try these on your own. Now these get a little bit trickier because you have a two-step equation. You have 2x minus 1, and over here 3x plus 2. So these are a little harder, so I might help you out with the first one. If you think about it, 2x minus 1 equals 1. What do you think the input would be? You could try a few numbers and plug them in and see what happens. Something minus 1 is going to be 1. So what minus 1 would be 1? 2 minus 1 is 1. So how do you get this right here to turn out to be 2? Well, that would be 2 times 1, correct? So the answer should be 1 here. 2 times 1 is 2, minus 1 is 1. So let's work backward and think about the next one again. We want our answer to be 3. We know that something minus 1 is 3. Well, 4 minus 1 is 3. So we know that 2 times 2 is 4. And 4 minus 1 is 3. So the input would be 2. How about for 5? Something minus 1 is 5. Well, 6 minus 1 is 5. So 2 times 3 is 6, which 6 minus 1 is 5. So our inputs are 1, 2, 3. Let's see if you can try this one. And we'll have Freddie give you the answer as soon as you've finished. So press pause now and try to solve the problem. Remember, you're trying to get to an answer of 17, 20, and 29. So ask yourself, what minus 2 is 17? And then think how you would get that. Oh, I mean, not what minus 2. What plus 2 is 17? So 15 plus 2 is 17. So you need 3x to equal 15. That's how you should think about it. All right, let's check your answer to D with our friend Freddie.
Hey, Freddie coming right back at you. For this problem D, it's a little bit trickier, but hopefully you got input values of 5, 6, and 9. If you didn't, make sure to pause and ask your teacher for a little more help.
Okay, the way he got those answers is he thought to himself, what plus 2 is 17? Well, that's 15. So 3 times 5 is 15 plus 2. For 20, something plus 2 is 20. Well, 18 plus 2 is 20, so this has to be 3 times 6. What plus 2 is 29? Well, 27 plus 2 is 29, so this is 3 times 7. That's how we got those answers. Let's look at this real-world example. The Gomez family is traveling at a rate of 70 miles per hour. That means 70 times the hours, which is right here. The function rule that represents this situation is 70x, where x is the number of hours. That's the input. Make a table to find how many hours they have driven at 140 miles, 280 miles, and 350. Then graph the function. Okay, so here's where we set this up with our inputs of we set this up with 70x, and our outputs are 140, 280, and 350. And we want to know 70 times what equals these numbers. 70 times 2 is 140, 70 times 4 is 280, 70 times 5 is 350. Remember, if you weren't sure what numbers go here, you could divide 140 by 70 and get the 2. Once you have this information, you need to make ordered pairs. To make ordered pairs, you take the input and the output. So your input is 2, your output is 140. Your input is 4, and your output is 280. And your last one is 5 and 350. Then you graph it. X always gets graphed first. So your graph looks like this, and you could make a line. Okay, go ahead and go to your next page. All right. I'd like you to try problem E on your own. Brianna bikes 12 miles per hour. That's this rule right here, 12 times x. The function rule represents the situation as 12x, where x is the number of hours. Make a table to find out how many hours she's biked when she has gone 12, 36, and 48 miles. The other way you can help yourself is you write hours here because you're timesing 12 times the hours, and miles here so that you know what to put in the boxes. So your answer is 12, 36, and 48. And you want to know 12 times what equals 12, 12 times what equals 36, 12 times what equals 48. Those are your inputs. Then you should create ordered pairs and graph the function. I'd like you to press pause now and do that. Once you have finished, Freddie will give you the right answers. Okay, let's check and see what your answers should have been.
Hi again. The answers should have been an input of 1 hour, 3 hours, and 4 hours. Your ordered pairs should have been 1, 12, 3, 36, and 4, 48, and they should have been graphed on the table.
So 12 times 1 is 12, 12 times 3 is 36, and 12 times 4 is 48. Your ordered pairs will be 1, 12, so you would graph that right about here. 3, 36, which will be 3, 36, right about there. And 4, 48, which will be right about there. Those are your ordered pairs. That's how you would graph this function table. Okay? Great job so far. You will actually be doing the guided practice in your C steps. Please answer this question. Which is the first coordinate in an ordered pair? Would it be y, x, or could it be either one? Please answer this question and show your teachers after you've answered it, or you can answer it in the note check and let them see it there. When you're done, please be ready to move on to part 2 of the function video.